find the sum of the finite geometric series.
What's the difference between a series and a sequence?
You're adding between them. The sequence is just a list of numbers. The series is when you're adding that list of numbers. You're summing them. That's when you have that summation. So yesterday when we dealt with the, what was the one we had? It was 81, 27, 9, 3, 1. That was the sequence. The series of that would have been 81 plus 27 plus 9 plus 3 plus 1 plus dot dot dot. Okay? That's what we're talking about. Now, it wouldn't be dot 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 because that would be an infinite one, so we'll say that it ends. That would be a geometric series. So in order to figure out the sum of a geometric series, we used that following formula. Excuse me. So the sum of the series is going to be the first term times the quantity, 1 minus r to the n over 1 minus r. Also remember when you're dealing with some of these, you have to go back to the generic rule every once in a while. Your nth term, first term, r to the n minus 1. Just leave that up there as well. Excuse me. So let's go through an example here. And like I said, this is going to be relatively straightforward. What's going to be weird is when you have to find the missing value. Okay? So let's use this one. Geometric series 1 plus 5 plus 25 plus 125 plus 625 plus blah, 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 blah. And I want to find the sum of 10 of them. Again, you've all recognized what is your rate, your R value? It's 5. So your first term is 1. Your rate is 5. Every time you're moving up, you're multiplying it by 5. We're okay with that? So if you want to find the sum of 10, well, again, it's going to be your first term times 1 minus your rate to the n over 1 minus the rate. Fill in the blanks. First term is 1. 1 minus r, 5 to the 10th power divided by 1 minus 5. What do you think you're going to use?
Calculator.
Your calculator. Again, when you go to use your calculator in a problem like this, just go right into the fraction form of it. Good morning. Go right into your fraction form of it and just type it in the calculator. Calculator will do the work for you guys here on this one. Don't worry so much about your first term out in front because it's a 1. If it was a different term, put it out there in front of the parentheses. But since it's 1, don't need it. So throw in your fraction, alpha of y equals.
So for these problems,
What's that?
so for these problems, the rate would be like out like x times
Yeah.
5.
Yeah. What's happening here is you're finding out when you're talking geometric,
Yeah.
the difference between the geometric and the arithmetic one. Arithmetic has that common difference. You're adding and subtracting.
Yeah.
Geometric, you're multiplying. There's a ratio, a common ratio. They just call it R.
So for this one, it would be like x, and it would be like 5 times, right?
Yeah, exactly. We don't have to write out the rule for these. The writing the rule, we're using the nth term. It's a little bit different.
Alright.
All right, and we'll have time today. I'll get you. Again, not so scary, right?
It's a lot.
So far. You guys know me too well.
But then you're going to do it with 2 equations and we have to find the thing.
Exactly.
Wait, that was the answer?
That was the answer.
Okay.
Like I said, when you just have to find the sum of them, it's easy. It's basically making sure you're using the right formula. The tough part comes in when you have to find out the value. Just like what we did with the arithmetic ones. Remember how we did the systems of equations? You had to go back and forth and do all that substitution and go for it. Well, what's going to happen here to find the specific sum of these values, bless you,
Thank you.
we kind of have to do the same thing. It gets kind of messy. So in this case here, we're going to reuse the formula. First term, 1 minus r to the n, 1 minus r. And we want to figure out how many of them do I have to add together in that series for it to add up to equal 3906? Well, we needed to know the first term of the series. What was it? It was 1. All right, the first term of that series was 1. What was the rate? 5. That was the rate was 5. Now, just like we did yesterday, or earlier, just substitute in. Substitute in what you know. Well, it's got to equal 3906.
Wait, how do you know A1 equals 1?
It was from this problem. It's just part B of that, that's all. So I know it's got to equal 3906. I know the first term is 1. I know my rate is 5. N is my unknown. And to start piecemealing it together. What am I have to divide? I'm dividing by -4, so how am I going to get rid of this? Good. All right, very good. So what's 3906 times -4?
115.
Was it?
It was -15.
Equals 1 minus 5 to the n. Everybody okay with that? Excuse me. All right. Now what? Do you want to do that, or you want to do with these things being positive? Oh. Yeah. Let's move the signs around. Just make your life easier. Move your signs around. What I'm saying here is let's get this 5 to the n over here equals 15, 6 to 5. Now, how do you get that exponent to drop? You what base? Very good. Remember that? You don't remember that? We're exponentiating it. Very good.
And it sucks.
No, it doesn't. It's a button on your calculator. You
It's so
baby.
weird.
Wait, what do you do? What do you do?
Log base it. Got a log base 5 on both sides. Say it. How do you log?
Alpha window.
Alpha window 5. Alpha window.
Logging over there.
Oh, log in.
Wait, there's a log button.
There's a log button. Log base 5. Alpha window, ladies and gentlemen. Alpha window number 5.
What do you do? Alpha window.
But now what's happening? You got to take the log base 5 of that 15,625.
You got 6.
And then log base 5 is log over log base
Yes.
5 log.
Yes. Yes.
Log over 5 log.
What is it? Wait, so n equals 6.
It's log of the 15,625 divided by log of
Because they
5.
cancel out, remember?
That should work.
Yeah.
Did it work?
No, we have to write out
I think that's it.
Math.
Go 15,625.
No, S of 6.
Man, it's really a couple buttons you gotta press. Huh? Jeez, no pressure here. We're not staring at you.
Log over 5. Now we're gonna
So your n value is 6.
That,
Okay.
do you keep
What
going
does the log
after
do?
that?
I did it.
No, you're done after that?
Yep. Did it work?
How does the log do that?
It's remember the logarithms is nothing more than working with exponents. It's how you undo working with your exponents. The opposite.
How does that calculate it out? What is a log?
A log means a base raised to some value gives you something.
There and cross it.
In order to solve for the exponent, you use what is called the logarithm. That's just what it's called as opposed to multiplying the power. It's 5 to some power gives you 15,625. What is that power that gives you that? Using what they call a logarithm allows you to do that. Why they started calling it logs, I don't know. Maybe because they sat on logs back then.
Everybody
Log,
wants to log.
log, take the Chevy's wood. Log. No, it's awesome.
That was awesome. We should watch it again.
Yeah, let's do
watch it.
that.
Last year, right?
Hey, we got someone. We got someone. There was a person.
No, it was a very bad picture from your book.
Oh.
In the book, there's a problem about cell phones. The cell phone is the size of her forearm.
Really?
Wait.
Look in your book.
Well, hey.
Yeah. Yes. Okay. 669. Yeah, it's awful. So let's try another one like that.
It's got these kind of the size of her arm too.
She's so happy.
I know she's very happy at that moment in time because she's probably paying $7 a minute for that phone call.
Sean Manning, they could take some
All right, take a couple minutes, try those two.